In part 2 of this course in modeling a 4-stroke RC plane engine, we will be creating the cylinder jacket. We will sketch, extrude the primitives, create the fins, add the holes, change the physical material and appearance, and then join the cylinder jacket to the crankcase assembly. Welcome to the Learning Channel. Let's make the cylinder jacket. Okay, so this is the goal for our tutorial today. We are going to finish the cylinder jacket. We're going to end up with the result that we see on the screen, but let's go back to where we finished off with our crankcase assembly with last tutorial. So again, with this, we're going to move at a little bit of a faster pace. Techniques have already been learned from previous tutorials in the past that you have watched on this channel and on many other channels. But let's get into it. So the first thing we're going to do is we'll create a new component, and let's just go ahead and call this the cylinder jacket. Very good. Everything turns transparent. We don't want to utilize any of this geometry right now. The fewer relationships that we create, the faster our Fusion file will run. So let's right click and isolate. Now I'm going to go right away into creating the primitives for our cylinder jacket over here, and we're just going to keep on progressing with one dimension at a time. I again encourage you, if you look in the description to this video, you can find the entire technical drawings and the plan book for this entire series and for several other engines as well. But as you go over this tutorial, print out the plans, check off every dimension to make sure that you're not missing anything. That's exactly what I'm doing. So I'm going to put in the primitive shape first, and that's the bore, and then I'm going to put in the outside diameter as well. And then I'd like to make sure that this is horizontally constrained right there. Now I'm also going to put in the dimension, which is 0.154. So I could have created this as the origin point or this as the origin point. I could have chosen between one of the two, but I selected this because that's the same point that is on our crankcase assembly. So let's do that, finish our sketch. And we can just extrude that right on up to the overall height. Now there's many ways of proceeding, but what I'm going to do is I'm going to proceed by creating the sketch on the bottom face over here. And I'm going to save the holes to the very end, but I want to create the fins next. So let's do that. Here I'm going to create section CC first of all. And since this is intermediate advanced, I don't want to have to explain that I am actually creating diameter dimensions instead of radius. That's just something that you should know why I'm doing what I'm doing. But anyways, if you need to know, if you need to understand further, please check out the beginners tutorials for members only. Now I'm going to create these radius values over here, these arcs, I should say. I've gone the opposite direction, so right click. Oh, that didn't do it for us. There we go. Oh boy, I'm all over the place now. So let's just create a line here from center point to center point. We're going to coincident constrain, and then I'm just going to mirror this to the other side. There we go. And now what I want to do is, well, we can specify this. This is going to be 1.25. But what I'd like to do is make this endpoint horizontally constrained to the quadrant point over here. So the way we have to do that is we create a point, go just like that, make sure that it's vertically constrained there, and then horizontally constrained right there. That should button everything down. Very good. Let's finish that sketch. Now we're going to start extruding everything. So let's do this. Yeah, let's pick that. There we go. And in fact, I'm just going to go back to our sketch over here, and I'm going to turn this center line, this symmetry line, construction line into a construction line. So let's do that. And now we can extrude these right there. Perfect. So this is going to be two-sided. We're going to go one direction and then two. We can go actually in the same direction, but we can specify different amounts. So let's put these fins in first of all. This value is going to be -94, and then the second value, we're going to go 0.094 plus 0.063. There we go. There's our first fin right there. And actually this fin and the next 4 fins are all exactly the same. So let's do that. We're going to go to rectangular pattern, features. I'm just going to pick that extruded value right there. And we're going to go to Z-axis up. We're going to make a quantity of 5. And then we're going to go to spacing. And the distance is going to be 0.07 plus 0.063. And there we have it. So we've got all the fins done just like that. That looks really good. Now, what else can we do? Well, let's put in the flats. So I'm going to create another sketch down here on the bottom, reorient it so I keep my sanity, and we're going to put those flats over here too. Okay, and I can just create a center line over here. I'm going to turn that into a construction line, make sure that it's coincidentally constrained to the origin. Perfect. Make those symmetric and create our dimension right there. 1.18, that's in section CC. Let's finish that. And now we can extrude those all the way down to, we're going to go to object, which is going to be right there. Okay, that's perfect. And then last but not least, we're going to create another sketch over here. And this is actually slightly different than the beginner's lesson, but it still works. So here I can just snap the concentricity right there. And this is 1477. Perfect. Let's finish that. And I can extrude those two as well, all the way to that face. Okay. So this is looking great. That's exactly what we see on the drawing package so far, this page number, or the sheet number. So make sure to check off all of your dimensions as well. Next, I'm actually going to do the top 2 fins based off of the top face over here. Very good. So we'll do that, and we'll put in the dimensions for this as well. So let's just type in all of that. And this is actually the radius value. So let's do this here. Times 2. And we can actually do the 3-point arc right there. I'm just going to make this mirrored to the other side. Let's do that. Mirror from there to there. Okie dokie. Turn that into a construction line. This is going to be 1.25 radius as well. And I'm going to make this endpoint vertically constrained right there. Okay, so we've got this, the top 2 fins are going to be this profile. So let's grab that, and we can go to, let's go to offset, no, let's go to object and grab this right there. And then we're going to pull that up. Very good. We can go 2 sides as well. Okay, perfect. So minus 70, excellent. And this is going to be 70 plus 63, just like that. And you can see the shape of this looks a little bit different than the other fins, which is perfect. Let's go back to rectangular pattern, select our extrude. Axis is going to be our Z axis. And this is only going to have one more. So one more instance. And we're going to go to 70 thou plus 0.063. There we go. And let's just reference this as well. This is on the drawing, 135. It actually says 125 on the drawing. But yeah, in this instance, it's all right. Everything is okay. It's going to work out. Okay, perfect. So we've got the holes now. All of the fins and all of the 3D features have been added. Now we'd like to add all of the different holes. So why don't we create it on the top face first? Right click, create sketch. Very easy to do it this way. I'm going to create another line of symmetry and turn this into a construction line. Very easy to do that, and then make it coincident to the origin. Perfect. Let's go to points, and we can add all of the points and their approximate locations, make them symmetric to our center line, and add our dimensions. And again, I like to place these in the same area as our drawing specifies. So yeah, there we go. Okay, now that we have all of those center points, we're just going to go to the hole tool and let's add them. There we go. This one's going to be going all the way through. It's not tapped. Doesn't matter if we pick flat or angle. But these are 0.126 and they're going to go all the way through. So you can see if we did the holes first, then our sketches for the fins, they would have had all this inherited geometry, or we would have had to do a bunch of projections, and it would have made this a lot more complicated. So this is a whole lot better just to save the holes to the very end. So let's go back and tidy everything up a bit. And I'm going to rename all these sketches according to the main aspect of each sketch. So for example, main body sketch, this is our section CC cutout. This right here, sketch 3, those are our flats. So I can just call that our flats, that's fine. Section 4 is the rest of our small diameter. So again, I could have doubled up on some of these, but there we go. Section 5 is our section BB cutout. And sketch 6 is our top face hole points. Great, that's looking great. So I'm going to reactivate that and we can go back to our hole over here and create these through holes as well. So these are going to be 156 through, and these are actually counterbored, as we can see, 0.25 by 0.32 deep. Excellent. So we've got those holes right there. I'm going to hide the sketch, and we can add the chamfers on here as well. So if we look at the notes, we can look at this, and we might have to adjust this later on. I'm just going to put on a 15 thou chamfer right there. And then add a selection set. So down here, we're going to have to calculate this value. So all we do for this, let's do an open bracket 25 minus 0.156 close bracket divided by 2. And that will create that. Now, if we want to see a section analysis right here, let's go to inspect section analysis. We're going to grab our YZ plane right there, and we can move this on over. We actually have a value for this, which is 0.239. That's right in the center of that hole. So we can see, yeah, we've created this 45-degree chamfer right there. It looks really good. I could even rename the analysis, no problem. And this is going to be our cylinder jacket section AA. And the section AA, you can see, is staggered a little bit. We can't do a staggered section analysis within this workspace of Fusion. We can do it within the drawing. But anyways, this works just fine. There we go. And so we can hide that. Don't hide your folder, but hide the individual section analysis. And that way, if we create another one, it won't hide it automatically. So that's that. Perfect. Now let's create a sketch on the bottom face here. And we can insert all our geometry here too. Here we don't have to add another dimension. We can just specify that and then say that it's equal to the other. Very good. And now the 3-point arc over here. Perfect. And this is in fact concentric to either one of these diameters. So we can just call it that right there. And what happened here? Okay, let's just delete that. And we're going to go 3-point arc. Let's make this tangent first of all. So that line and that right there. And now I can say that I want it concentric to that. And it should place the center point at the exact same location, which that's the root meaning of concentric. Okay, so now we can extrude those two features. And again, we're just going to check off every single thing on our drawing to make sure that we haven't missed anything. Let's bring back that. Well, I can rename this sketch the bottom face feature sketch. Okay, let's make that visible again, and we can extrude this down, minus 0.37. There we go. So this is looking great. This is looking very, very good. Perfect. So now what do we do? Well, let's just save it just to make sure we don't lose our model, and we make sure Fusion doesn't crash. Now the next thing we're going to do is put those side holes in, both interrupting our valve holes over here and then the set screws that go in the back. So I think the easiest way of doing this is just creating an offset plane. I'm going to create it on that. I'm going to bring it down to the middle of those holes as well, since I know exactly where they're located, which is 0.239. Perfect. Now if I create a sketch on that construction plane, I could also go slice, and it slices that whole part right in half. Then why don't we put in our circle right here? So center diameter circle, this is going to be 2.5. And we're going to make this right in the middle of our hole over here. So let's just project. Let's use project. It works so well. We can project our hole over here, and we can make sure that it is dead center. So I'm going to turn these into construction lines right there. And we can also create a line from center to center like that. Very good. And now if we want to snap this center point to that line, we just have to put in our vertical direction over here. So let's do that from there to there. And it creates a projection line all the way across, which I don't really like. So what can we do instead? Let's go D, and I'm going to go right to that feature instead. There we go. So it creates a little projection line instead, which is fine. And this is 0.23 deep. Very good. Finish that. We can extrude this now, and we're going to go this direction and go all the way through. Since it's exactly the same on both sides, I can just create a mirror using the mirror tool, grab that feature. It's easy to grab it in the timeline, mirror plane. We can grab the YZ and optimize. That sounds great. And you can see, there we go. Perfect. Now, last but not least, we're going to create another offset plane, and we're going to make it in line or tangent to this edge, or the end of our cylinder jacket over here. So we just look at our diameter is 1.6, so we go 0.8 plus the offset of the bore, which is 154. Okay, that looks great. And we'll create another sketch. We could actually just right click on that and go, no, we can't create a sketch that way. So we have to go create and create sketch on that construction plane. Perfect. Now I'm going to press P for project, and I'm going to project this right there and our bottom. I guess we don't have to project that. I'm going to create a construction line going down to the origin, just like so. Perfect. And we can create our 2 points right there and there. Let's make them symmetric to this line. Put in our dimensions. It's actually from there to there, 0.4. And from the top down is 0.23. Excellent. And because we've created it on that construction plane, the normal will be going right into the center of those bores right there. So let's create a hole there and there. This is going to be tapped. It's just going to be simple. There we go. And this is a number 256. And this is the cool thing. We can just see how far we want this to go down. This will be on our drawing later on. We can just specify a depth to make sure that this goes where it's supposed to. So I think this is looking great. Let's just save that. Now let's remember to do this. We've got these two other sketches. We can do, what is this, section AA hole location. And then back here is our 256 hole location sketch. All right, you might have better names for these as well, but the whole point is to keep it organized, well organized. And the construction here as well, we could also rename these, right? We could call this section AA, and plane 2 is going to be tangent plane for 256 holes. Now let's right click physical material, and we're going to look for aluminum 2024. And as we see, there is no aluminum 2024. So I'm just going to grab 2014, drag and drop. There we go. But I would like to add a little bit of pizzazz to this as well. So I'm going to go A, and we're going to assume that this is all going to be anodized later on. So let's go to this anodized rough blue. I really like that. And we could make the entire thing blue. And then what we're actually going to do, we don't want this entire part to be anodized. We're probably going to have to bore things out and ream things out later. So I'm going to go to faces here, and I'm going to drag and drop where the part is not going to be anodized, because we're going to remove that material after anodization. So I'm just going to go like this. And in fact, we can pick multiple faces. I can just hold down Command or Control on a Windows computer, and once we drag and drop it, we'll put those, all the faces that we selected, we can drag and drop just like that. And that looks great. I'm going to do the same thing over here. I'm going to hold down Command and pick all those different faces, and then just do one drag and drop. Perfect. That will be like that. And last but not least, right there. So this is looking really good. Perfect. And now let's go and join it to our crankcase assembly. So remember, we isolated this. I'm going to go unisolate. We're going to actually activate the top level component, master assembly, move that on up, and we're going to join. And it's this to that. So we're going to join the cylinder jacket to the crankcase. Where's the best spot? Well, we can actually select several different spots, but I think the center of this bore is probably the best. It's very easy. Again, if we just pick the face, and then it forces us to, let me just hide the, there we go, the crankcase. It forces us to pick a snap point on that face, including centers of bores. Let's turn on the crankcase assembly. And the same thing, I'm going to pick that face and then the bore right there. And you can see all of our holes line up perfectly. This is looking great. There's no motion. This is going to be a rigid joint. So there we go. That's looking great. Now let's just isolate our crankcase assembly and do the same thing. I'm going to go to A for appearances. And here I think it's going to be a whole lot easier to just go to faces and pick the faces that we want anodized or no anodization on them. So I'm going to pick all those right there. And let's just drag and drop. There we go. Perfect. Do the bottom down here as well. And I think that's going to be great. So we're going to anodize and then we're going to mill out all those features later on. So that looks great as well. And last but not least, I'm going to go to the joints over here and make sure that this is renamed. So again, this to that, we're going to go cylinder jacket to crankcase and then hide that joint right there. So let's make everything visible. And what do you think of our assembly so far? So we've created the crankcase assembly, we've created the cylinder jacket, everything is looking great. We've applied appearance. All of the materials are correct except for the 2024 because we didn't have aluminum 2024. If you have benefited at all from this tutorial so far or the series, please like. If you love us, please consider subscribing. And if you love our channel, please consider becoming a member. We've got YouTube membership and Patreon membership. Again, all of our members will be able to watch all of the beginner series, which we're releasing ahead of time. And you can go through the ins and outs, different ways of modeling as well, why we create our model the way that we have created. And there's different options as well, how relationships are formed, how we need to be careful of different workflows and things like that. That's all described within our beginners members only videos. So hope that you check it out if you're interested. Our next tutorial is going to talk about the crankshaft. And if you look at the plan book, the crankshaft is made up of all sorts of different components. So again, we're going to be creating an assembly and then making the crankshaft assembly together. So until then, thank you for learning with us and hope that you continue to learn with the Learn It channel.